Hello, and welcome to your next home learning video. Today we're going to look at thermal energy transfers. Remember to copy down the volt and find the keywords within the width. Remember, we're only looking for 3 keywords. So, by the end of the lesson, you must be able to identify energy transfers by conduction, convection, and radiation. You should be able to describe how thermal energy is transferred through conduction, convection, and radiation, and you could be able to explain how to reduce heat loss from houses. So, what is a thermal energy transfer? A thermal energy transfer is the movement of heat energy. This can be done by 3 different methods depending on what heat energy is moving through. The 3 methods are convection, conduction, and radiation. We're now going to look at the 3 types of radiation in a little bit more detail. Okay, so the first thing we're going to look at is all 3 energy transfers. Okay, so the first one, conduction. This happens in solids. Radiation. This happens in gases and through space. And finally, convection. Convection normally happens in fluids, so liquids and gases. We're now going to look at them in more detail. Conduction in metals. Metals are very, very, very good conductors of thermal energy. If we have a look at this diagram, what is shown is showing the particle model of thermal energy transfer. So as you start heating up the metal, first of all, one row of particles starts heating up, and then the energy will transfer to the next row of particles, and they'll start heating up, and then the next row, and the next row, and the next row, and eventually the heat energy will transfer through all these particles. If you keep the source of heat on these particles, i.e. a flame, what will happen is that heat energy will keep moving up the rows of particles, so eventually the whole piece of metal becomes hot. We have convections in liquids. As you can see from the diagram, there's a flame heating some water. What happens is the heat causes the particles to gain more energy, and as these particles gain more energy, they start to rise. As you should already know, that heat rises, so this is a really good demonstration of this happening. The water particles start getting warm, and they start rising to the top. As they get to the top, they start cooling down, and then eventually they become so cold they'll sink back down to the bottom. This is called a convection current. And then finally, we have a convection in gas. So when you got your radiator on in your house, what happens is the cold air goes to the radiator, it warms up, it rises, it transfers around the room until it eventually cools down and then sinks again. And then this will travel along the floor and back to your radiator. With most houses, you'll probably realise that the radiator is right underneath the window. I want you to think, is this the most efficient way to keep your house warm? Would the heat energy transfer through the window? Just a little question for you to think about. And then finally, we have radiation. Radiation is the movement of heat in gases and through space. It does not require particles to travel. This heat radiation is normally infrared radiation. The hotter the object, the more infrared radiation is emitted, and dark non-shiny surfaces normally emit and absorb more radiation than light shiny surfaces. So that's why you'll see that when you want to keep something warm, like after a run has been running, they'll wrap them up in tin foil. That's to keep all the heat energy inside to keep the person warm. And then finally we have a diagram showing the heat energy from the sun being transferred to the earth. So radiation is the movement of heat through gases and through space. Right guys, hopefully by the end of this lesson you understand what thermal energy transfers are, most of you should be able to identify energy transfers by conduction, convection and radiation. You should be able to describe how thermal energy is transferred through conduction, convection and radiation, and you could explain how to reduce heat loss from houses. Thank you very much, and see you all in the lesson.